Hello and welcome to our 8th annual HPCC Systems Community Summit. We've been doing this several years. We have done this throughout normal years and pandemic years as well. And this is an event that is really close and dear to many of us. I would say that almost every community member has been involved in some way throughout the years. This year, of course, as you can see, is an event that we do in a virtual manner, similar to what we did last year. But we've been working through this to, of course, make it better every time. And in this particular case, we added a significant amount of content that we will go over through in the next several hours. We have 30 different presentations, and many of those are in the format of breakouts. So you will need to choose wisely because there are 5 different tracks throughout the day. We also have some plenary presentations that we will have right after this, first segment. And those include keynotes from great speakers that are part of our community. And we will have even training, and you are probably getting also acquainted to this from previous years as well, which will be done throughout Tuesday through Thursday. And this training will include the practical use of HPCC in a field that many of you are either part of or interested in, which is machine learning and AI. And you will see throughout this training how you can practically learn, even if you have no previous knowledge, in just a few hours, how to get this to use it in practical ways. But before we go to all of this content, it is really a pleasure to have you here. I thank you very much for dedicating this time to our community, to us. I really believe that we did the best we could to assemble a lineup of presenters and speakers that is top-notch. And I hope you will agree with me on this. But there is something that is also very special about this year. This is our 8th annual community summit, but it's at the same time our 10th anniversary of our open source HPCC Systems project. And, you know, 10 years really don't go by, even though they went very fast, without a lot of effort and without a lot of change. In these 10 years, I think we all learned a lot. We all changed things that we did before. And because HPCC Systems has been around for 20 years as a platform, we have a lot of experience before that, but nothing compares to the last 10 years. The fact that we got so many people, so many brains together to make the platform better, to bring others to the community, to improve our documentation, to strengthen our process, to create a truly community sense of like-minded people applying this technology for a number of different domains and in a number of, many times, innovative ways. We, I think, changed radically the way we operated, and we made the platform cover a new life in the context of so many changes that happened over the last decade. Who would have thought that we would see changes in the way communications happen across the world? Cell phones weren't that popular 10 or 15 years ago. Applications on your smartphones, well, they were almost non-existent back then. Things like Bitcoin and blockchain almost didn't exist, were just upcomers in some papers. And certainly big data technologies and machine learning and AI has grown significantly over the last 10 years. Of course, as a side effect of this, also the software development methodologies, the technologies around developing software in large communities have also changed. All of the advent of the cloud environments and the adoption of cloud for many mainstream technology applications has been also tremendous. And as part of that, as many of you already know, in our 8.0 series of HPC systems, we have embraced cloud environments and built support for cloud deployments in a way that truly leverages all of these native capabilities in the cloud. But none of this could have been possible without an open source project, without an open source community that helps us drive these new ideas, implement things, bring new use cases, and test. This is just a testament of how much you made this possible. And I hope this entire day is a way to give you something back with all of this content, help bring all of us together, learn new things, and certainly enjoy, have some fun as well. And of course, I wouldn't just end my talk here. I would like to bring someone that is very close and dear to me and probably to you as well. This person is Richard Chapman. He is the person that leads and have led our core HPC systems software development for the last 20 years and has been absolutely key to bringing HPC systems to an open source community, to building all of these new capabilities on top of everything that was there. He's never feared to disrupt old established things and bring innovation into it. And all of this is quite visible throughout the platform, the community, and the software development methodologies that his team and many others apply across HPC systems open source. He has been also key to build some of the capabilities that we are now introducing in our 8.0 series. As you know, 8.2 is out there in production-ready manner. 8.4 is about to be released or has been released just recently. And Richard will tell us a little bit about his perspective, which is a lot to say for the last 20 years, but also his perspective on the open source project. And this is particularly key at this point, where we are, again, celebrating our 10 years anniversary for this community. So Richard, welcome, and please tell us a little bit about what you think of our HPC Systems platform today in 2021.
Well, thank you, Flavio. As you say, a couple of years ago, we were celebrating the 20th anniversary of the birth of the HPCC platform, but this year we're celebrating another significant milestone, 10 years since we released HPCC as an open source platform. When the idea of going open source was first suggested, it was a little controversial. The development team were, for the most part, pretty keen on the idea. I think most of us took the view that we were proud of our creation and we wanted as many people as possible to get the chance to use it. But our CEO at the time and the Reed Elsevier board took a little more convincing. After all, it wasn't that long since they'd paid a sizable chunk of money for Sizint, at least in part for the technology. And they'd also spent the last few years telling shareholders how important this technology was to the company's value. There was also money being made in large contracts, licensing the technology to various US government users. Why would they now want to give it away for free? Those of us in favor of the open source proposal argued that open source did not prevent support contracts for the government customers, that sharing the technology didn't stop us being the experts in how to use it and get value from it, and that we were not proposing giving away any of the ECL code that we ran our business on, just the platform that ran it. And we argued that open sourcing the platform could have some major benefits for the business. The most compelling benefit was that an active community of ECL users outside the LexisNexis company would make it easier to recruit and retain the ECL programmers that we need. It's easier to persuade someone to invest a chunk of their career becoming proficient or indeed expert in ECL if it's not locking them into a proprietary technology. Other potential benefits lay in the ability to receive contributions to the platform source from outside the company, free labor. Contributions can take many forms, from code contributions that can be merged into the source as is, to bug reports, to suggestions for improvements or new features. In the end, the arguments in favor of open sourcing won the day, and we set about preparing the sources for release. There was quite a bit to do. We needed to reorganize the code to separate any portions that were to remain proprietary, either because they were considered sensitive or because they were so specific to our internal needs that we did not feel they would be helpful to share. There were also some parts of the system that were deprecated, and we only kept them around for back compatibility that we didn't want to include. We needed to change the build process to something more standard. This is when we adopted CMake. We needed to change the version control system to something more standard, and this is when we switched from Subversion to Git. We needed to clean up any version control history that might reveal those parts of the system that we were not open sourcing. So we actually started with a clean history once we finished the code reorganization. And we needed to scan the entire code base to make sure that we were not including anything that was not ours to open source. This whole process took around 6 months after the decision had been approved, until finally, in July 2011, we pushed our first commit to GitHub and announced to the world that HPCC was now open. So looking back, how has it turned out? Did open sourcing the platform give us the benefits we hoped for? Were there any downsides? Benefits, yes, and more that we had not anticipated. We've had contributions to the code base, not a huge volume, but very useful. We've had bug reports. We've had ideas and suggestions from the community. One of the most significant additions to the platform capabilities in recent years, the ability to embed Java code and other languages within ECL, originated in a submission from an external user. We've also been able to run an academic and intern program that would have been virtually impossible without an open source platform for our partners to use. We even participated in Google's Summer of Code program. But some of the other benefits were ones we did not anticipate at the start. The fact that we are running an open source project means we adopted many practices that we might not otherwise have done so, at least not so quickly. For example, the use of GitHub pull requests, code reviews, continuous integration and testing, and so on. It has also kept us honest in the sense that we always consider the wider and longer term implications of any change, rather than being tempted to put in quick fixes or special case code for particular short-term needs. Downsides? I honestly can't think of any. At least from the point of view of the development team, it has all been upside. And would I do the same again with hindsight? Absolutely, except I would have done it sooner. And with that, I'm going to pass you back to Flavio to close this plenary session.
That was a great presentation, Richard. It is just unbelievable when you go down the memory lane and start looking at the progress that we made throughout the years. And as I said at the beginning, it is just a testament of how good an open source project is for the overall technology, but also for its community, for all of the community members, and how it is shaped by the community. I just was listening to you, and I saw that each one of the references that you made on the benefits that we got are so true. And yes, absolutely, I would do it again, and I would have done it earlier, as you said. That was really good. So before we just get too entangled with the history of the 10th year anniversary, I want to introduce our next speakers. As part of this central block of plenary sessions, we have two great talks coming right after this one. So stay there, don't go anywhere, because our next speakers will be from Microsoft, and they are Krishna Kosei, who is a senior cloud solution architect, and Steve Griffith, who is a principal technical specialist. Both are in Cloud Native Global Black Belt team in Microsoft. Now, as you can imagine, this must have something to do with the cloud. And you are absolutely right. This is about HPC systems in Azure. Of course, everyone is familiar with Azure, which is one of the largest public clouds in the world. And Krishna and Steve have been instrumental to help us deploy and test HP systems on the cloud. They have been also part of a very strong collaboration between LexisNexis Resolutions and the Resolutions Group in general and HP Systems and Microsoft. And they can help us implement HP systems in a way that can be a foundation for a data lake on the cloud, on Azure, and certainly will help us bring some perspective into Azure integration with some of the Azure services as well. Of course, as part of this, there are new skills that you might want to learn, and they will also give us a brief overview of some of the Azure certification paths that you could take if you wanted to go in that role. Now, after the presentation from these two excellent speakers from Microsoft, we have another presentation, and this one is from someone who is in the financial services industry, Stephen Pear. He is the CEO of BitPay, and Gracie Ortiz, who is the COO of DataSeers. Both will tell us a little bit about what they say is a crypto customer journey. Yes, BitPay is in crypto finance, and they have been using HPCC systems as part of the DataSeer solution to do some quite interesting applications around transaction validation and transaction monitoring, and solving some of the big important problems with cryptocurrency and finance and compliance validation in this modern world. So we have two great talks coming. We have the great talk from the Microsoft folks about HPCC systems on Azure, and the one from DataSeers and BitPay about the use of HP systems in a financial services technology fintech type company. And of course, this is just the beginning. These plenary sessions are just the small starting opening to a great day. After that, we will have all of our breakout sessions, and be ready for a treat there, because we have 25 breakout sessions today. Please select carefully which ones you want to watch now. They will come right after the break, after these two sessions. And the ones that you can't watch, because there are parallel tracks, as you know, 5 parallel tracks, you can watch later on the recordings. So there is plenty of content for you to enjoy today, but there is also plenty of content for you to enjoy for the rest of the week and the rest of the next few weeks. Thank you very much. Thank you to you for making the time. Thank you to our speakers now for these two keynotes, and I'll see you around.
Hi, everyone. Thanks for being here. We're going to talk a bit about HPC systems on Azure, the work that we've done over the last year and a half and more, and what we're looking to do in the future. So first, let's do some quick introductions. So my name is Steve Griffith. I'm part of what Microsoft calls the Cloud Native Global Black Belt team. I'm a principal technical specialist on that team. Before I was with Microsoft, I spent years and years at Accenture and Duck Creek building solutions in the cloud for the insurance industry. Since I've been at Microsoft, my focus has really been on Linux and open source technologies, in particular Kubernetes. The team that I work with is really here to help customers build solutions in Azure on our open source stack, our cloud native stack, Azure Functions, all of those cool components that we have available to you. And I'm here with Krishna.
Hi all, again, Krishna Kosei here. I'm a cloud solutions architect at Microsoft. My main focus areas are cloud native apps, microservices, DevOps, and all the automation part, actually. I've been with Microsoft for the last close to 4 years and all. With this team, actually, we have been working, as you mentioned, for last 1.5 years now. All right, so let's start with basics, actually, or rather essentials. So what's Azure, right? So most of you must know Azure or must have seen the Azure, but just to level set, it's a cloud computing platform which offers more than 200 products and capabilities across many classes of services. You might notice in here as well that we have edge devices as well now. So we have extended to the edge as well. So with that, this gives you an opportunity to code in the cloud and move to the edge seamlessly and deploy the same code on the edge as well, or on the edge devices as well, right? We do have dev tools and DevOps services as well in here to help developers or empower developers and help them innovate more rapidly and use all infrastructure available in here or all the PaaS services that you see in here. Now, Azure is global service. We have more than 60 data centers, or sorry, more than 60 regions across the globe, actually, with almost 160 data centers. And all of these regions are interconnected by one of the largest interconnected network on the planet, actually, right? So you can deploy your apps where your users are or close to your users, actually, right? So that Azure is truly global service. Now, let's start with how we work with the team and how we collaborated and all, right? So as I mentioned that we have been working with the team for the last 1.5 years, right? So the team started with these two initiatives. One is that enable HPCC on Kubernetes. So what does that mean is that utilize what Kubernetes offers fully, and then follow the cloud-based practices and ensure that HPCC remains performant and efficient on the cloud while porting the HPCC platform on the Kubernetes, right? The second initiative that we have been working with the team is Migrated to Cloud, right? So migrating to the cloud takes planning, designing, testing in the cloud, and making sure that your workload remains cost-effective and resilient in the cloud, right? So these are the main initiatives that the team is working so far. And this is still work in progress, actually. Now, as you see here, we have like 3 virtual teams in a way, right? The first one on the left you see is HBCC Dev Team, right? So this is the team who's enhancing the platform, implementing it on Kubernetes, following all the best practices and all, right? On the right side, you see is Cloud SRE or COE team. So that's the team which who is using whatever the HPCC is releasing, it's testing and providing the feedback to the HPCC team as well, right? And at the bottom or down below, you see that Microsoft team actually. So we are kind of there to support the team, answer any questions, help the team follow best practices, and all other aspect of cloud, actually. If there's anything that they need, we are there to support, actually. But all in all, the idea for the whole team is that we sort of have common goal, actually, right? We work towards those 2 common initiatives or those 2 common goals. Back to you, Steve.
Yes, so let's talk a little bit about the focus areas that we had over the last year and a half. So first and foremost, we were trying to come up with what was the common goal that we all wanted to achieve. And to get there, to have a common goal, you need to have baselines, you need to have benchmarks that you can work against. And that, it's a bit of a challenge because HPCC, the platform, has a lot of capability. There's a lot you can do with the platform. So creating a kind of simple test can be challenging. So what we did was we worked with the HPCC team to confirm, how they typically start off with benchmarking. And the most common way that they do that, in many cases, in particular with new hardware testing and things like that, is to work through a TerraSort. So we worked with them to understand how the TerraSort process works, find some specific targets that we could try to achieve, some very basic targets, and then start to actually implement that on Azure. So to do that, we wanted to take Kubernetes out of the picture to start. There's a lot of moving pieces in Kubernetes that can add a good bit of additional variability in your testing. So what we did was we started with some just basic VM testing, right? So taking a virtual machine, installing HPCC components, and running through those different tests. Establishing some level of baseline for what the basic VM configuration would be in Azure and what the test results were from that, and then make some modifications, make some adjustments. We'll talk a bit more about what some of those adjustments were in a second, but then benchmark test against that and identify what the optimal configuration is, or at least one of the optimal configurations that we could then bring forward into AKS. Once we had that, we were able to start looking at Kubernetes and Azure Kubernetes Service to apply some of those changes. Now, the fortunate thing with Kubernetes is it gives you a lot of flexibility. So the ability to pretty much tune anything out on the hardware and on the Kubernetes platform itself to test out different configurations. So we were able to make operating system changes through things like privileged daemon sets in the Kubernetes world and try different storage options. So what were some of those changes that we made? First, looking specifically on the Kubernetes front, there are a lot of capabilities that we can tap into, like I mentioned. And one of the first things we identified was the fact that we may want different components of the HPCC platform to run on different machine types or machines with different configurations. Azure organizes its machine types by what we refer to as SKUs, and those SKUs have different hardware capabilities, right? So different processors, different attached storage, and things like that. So we needed a way to leverage that, and Kubernetes provides a capability called taints and tolerations, along with node selectors that allow you to say, okay, I want this set of components, or these, what Kubernetes refer to as pods, to run on these nodes, and I want these components to run on these nodes. So we worked with the HPCC team that was developing the Helm charts. Helm, if you're not familiar, is the mechanism you use to deploy applications to Kubernetes, or is one of the mechanisms you can use to implement into the capability the idea of placement groups, so you could identify which the target environment would be for different components. We then looked at specific Azure configurations that we could tap into. So one being, I mentioned already, the machine type, the SKU. Some of those machine types have optimized local storage like NVMe disks that we could leverage. Others had different CPUs and things like that. So we started playing around with those. So we developed a series of tests where we could quickly swap those things out and try to find the machine type that worked best. In addition to that, as part of the outcome of the VM testing, we identified some optimizations around the networking stack. That included both accelerated networking on Azure. So certain machine types, as you're looking at them, support accelerated networking to get you, north of 25 gigabits per second on the network. And then in addition, there was also things like the MTU setting. So globally, Azure has a default MTU of 1500, but you can actually adjust that up to 3900 to get some additional performance benefits out of that as well. So looking at those changes, applying those changes, using things like privileged daemon sets and the placement groups to take advantage of those things. The next, we moved into the Aks Best Practices. Now, fortunately, there weren't a lot of demands from the HPCC side to drive Aks Best Practices, but things as simple as separating the system pools from user pools. So by that, I mean things that run the Kubernetes system go into one node pool, and things used by HPCC would go into another node pool. So that gives you that separation. Auto scaling as an option. So playing around with the ability to automatically scale up as demand increased and automatically scale down. And then finally, looking at the storage options, right? So I mentioned already NVMEs, but then in addition to NVMEs, there's a number of storage options. Azure being a public cloud, all public clouds provide a number of storage options, ranging from object storage through Azure Blob, through Azure NetApp Files and Azure Files, which provide network attached storage, HPCC Cache, which is a high performance cache storage. And then more recently, we released NFS v3 for Blob. So this allows you to access your Blob storage, your object store, across the NFS v3 protocol. So we tested a number of these, and ultimately, we'll cover this more in our deep dive session, but ultimately landed on a combination of a couple of those storage components to optimize the performance of the HPCC system. With that, I'll hand it over to Krishna to talk about scaling.
Yeah, now, thank you, Stu. So now, as I mentioned that we have been working with team for past 1.5 years. So when we started, not many of the team members were skilled on Kubernetes or Azure for that matter, actually, right? The team is super smart. The dev team, the COE, SRE team are super smart, but there were areas that needed scaling actually. So we work with the team. We had couple of weeks working sessions every hour, every day, 1 hour or so actually, to scale up actually, right? And teams rapidly ramped up on scaling as well, right? They grasped everything and they started using Kubernetes and Azure very fast, right? And then this is the most exciting part of the job actually, right? The feedback. So the feedback from us to the team and the feedback from them to Microsoft actually to us, right? Now, one like feedback from us to them would be something like, hey, we see that this in Helm chart, can we use something that is native to the Kubernetes, for example, right? So like 10 toleration and all that. Like for that, the HPCC team released something called placement groups actually. Right, so that's one example. The other example for the feedback is that they gave the feedback to us actually, right? So for example, when we tested a couple things were not performant enough actually for storage, right? So we work with them on that feedback and help improve the storage service, for example, right? The other feedback that we have implemented in products actually is about MTU. So when we were testing HPCC clusters, running tiers or jobs and all, and we had to configure couple network things, and one of that is MTU, right? So that's one of the feedback that we got from the team, and that feedback we took to the product team, and now they are implementing that as a new feature in AKS actually, right? So this sort of a loop between us actually, and with that it helped us and it helped the team as well to follow the best practices and make HPCC super fast and performant on the cloud actually. Now, the example of the collaboration is this. I just talked about that briefly. So when we were testing HPCC, we saw that HPCC is sort of hitting the storage account limits actually, right? And then we sort of dig a little deeper, like why it's hitting those limits and all that. And then it turns out that HPCC, by default, it's writing every file parts into a single directory actually, right? Now that we saw. But on the Azure side, actually, there isn't much that we can do. I mean, there is something that we can do. So for example, each Azure service has its own soft and hard limits actually, right? So if you take storage account, they have its own limit. If you go other service, there is some limits on that actually. Now, some limits can be relaxed, but for some we need to work around those limits. Now, to address whatever the issues we were having, that HPCC cluster is reaching the limits of storage count and all that. So what we did was we went to storage team, Azure storage team, and asked them, can we relax some limits actually, right? So what they did was they relaxed some limits on the throughput side, like they gave us almost 400 Gbps bandwidth to run the Azure, to run HPCC on Azure, right? And the other side of this is that the HPCC team enable a directory separation for writing files to the storage account, right? So we did something on Azure end which helped improve the performance. HPCC Dev Team did something on their end that they implemented this new feature, right? So the result is that we were able to run the job with almost like half the runtime actually. Whatever used to take, say, for example, 2 minutes, was taking just around 1 minute or even less than that actually, right? So that's the sort of feedback loop and the collaboration that we had with the team. And this is the quote from Flavio. Like Flavio really liked the progress that we made, and the this is specific to NFS blob NFS storage. That when we implemented that, it linearly increased performance and so on, right? Now, one thing about this is that this and there is link here on this page or on this slide to a blog post that we had posted on the Azure blogs. So this sort of activities help storage team as well to validate their services as well, right? Because HPCC is so performant, like it runs on hundreds and thousands of machines and all that. It sort of help validate storage services as well and improve. If there is anything that they need to improve, they were able to do that. So it's helped both the teams actually. Now, this is again interesting part actually, right? So far we have been testing HPCC on AKS attached to a couple storage services actually, right? But if you think of HPCC as in a data lake platform for your org, right? Or you can think of HPCC as your foundation for your data lake actually, right? Now, on premises is different story actually, right? So you will have your HPCC and then you'll have a couple DBs or other things connected on there actually. But once you are in the cloud, there are so many opportunities or so many things that you could do with the data actually, right? So this is very high level indicative architecture, how HPCC can run on Azure, right? So you see here, we have a couple areas like source, we have sources, we have ingestion layer, we have storage, we have serve, and many other things as well, right? In here, so you see that we have in ingest, for example, we have Event Hub, right? So Event Hub is a streaming service, streaming data service actually, where you can stream the data. HPCC does support Kafka, for example, and Event Hub does have Kafka APIs as well. So you can really use that to stream the data into HPCC. We have Azure Functions, for example, right? So Azure Functions can trigger your HPCC jobs or run a query actually, right? Or other way is that if you have your ECL, which would call REST APIs, they can call the Azure Functions as well, right? The other thing that is in here is that it since you have the data already in here, you could very well run more things on your data. So for example, all the machine learning, you can integrate all your data and run some data models and all with Azure Machine Learning Studio, for example. Your data scientists can use data science virtual machines to create some models, run things or run trainings or create trainings or models actually, or create experiments. The other thing is that once you have your model ready and all that, you can definitely deploy that on AKS, for example, and then you can serve that model or inferencing through API management to other apps and other services as well, right? The other thing that you could do once you have the data ready in Azure or storage, you could run Synapse Analytics on top of that, or you could have a nice dashboard created with Power BI and all that, right? So all in all, the opportunity and then opportunities are a lot in there. You can do a lot of things in longer run actually, right? And apart from that, you will have all the platform support in here, like you will be able to manage your costs nicely. You'll be able to secure your cluster nicely and so on actually, right? So this is basically big picture that you see in here that you can implement once you're on Azure or once you're on the cloud actually, right? So basically your HPCC could be a foundation to your data lake actually to start with. Right. Now, a little more about Azure or learning opportunities as well. So for example, if you want to learn more, or if you're a developer and want to learn about dev services or how do you deploy or develop apps on Azure, for example, or if you're a data engineer and you want to learn or offshore certifications on all that, there is a Learn portal. We have the link in here. So you can go visit that Learn portal and basically you will get a path for your role, and then you can learn through learn through our opt-out certifications as well. It's self-paced as well, so you can invest time whenever you have it, and then learn and then opt for certifications as well. Now, resources. So we have a couple code repositories in there and all the links to whatever we discussed so far in here. If you would like to read more about any of these topics or services, here's the link to resources actually. And if you have anything more to ask us, or if you have any questions or so on, please reach out to us actually. And thank you.
Yeah, I think it's been a great relationship that we've had with the HPCC team, and I know that our engineering team has benefited greatly from it. We constantly get feedback from them. We constantly get requests from them to run additional tests. So, we thank the HPCC team for helping us with that and giving us some really good real world scenarios that we could test out some of our storage options and really push the limits on it. And we believe that we've been able to give some good feedback as well to improve, the Helm charts and the deployment mechanism for HPCC, not just on Kubernetes anywhere. You can run this on any Kubernetes instance, but in addition, you're running it on AKS. So it's really been a great opportunity working together, and we thank HPCC and we thank you all for being here today.
So good afternoon. It's nice to see everyone here. And I'm Gracie Ortiz with DataSeers, and we've got Stephen Pear, the CEO of BitPay, with us today. So Stephen, I want to thank you for joining me today on this video conference. And I'm really excited to have you. I wanted to ask you a few questions just so that the audience can really learn a little bit more about who BitPay is and then what exactly you all do with BitPay. So if you can just give me a brief introduction to our audience and let them know who is BitPay.
Well, sure. And thanks for having me, Gracie. BitPay is actually the world's oldest cryptocurrency company. And what we do is we enable companies to allow their customers to pay in crypto. And we support a number of different cryptocurrencies, a number of different blockchains. But our merchants on our platform can accept payments from people all over the world, hundreds of millions of people at this point that have cryptocurrency and cryptocurrency wallets. And we support over 90 different wallet apps for payment, including our own. So we've been doing that for a little over 10 years now, and going strong and just building a great platform that manages the end-to-end payment workflow that a company has to deal with. We also have a consumer. I mentioned we have a wallet. We do have a consumer platform as well, where people can store their cryptocurrency, also sign up for a MasterCard to be able to easily convert their cryptocurrency into a balance on that MasterCard and spend it wherever MasterCard's accepted. We also have people can buy gift cards in that app with their cryptocurrency. They can also buy cryptocurrency from within the app.
Oh, wow.
We do on the business side. We also do invoicing type of payments. So professional services companies will use it to send out and bill their customers and give them the option to pay in crypto. And then some companies also use our payout service, which allows some of our customers use it for payroll to allow their employees to receive part of their paycheck in cryptocurrency. So
wow.
Anything involving cryptocurrency and payments, we've got a great platform that companies can use and consumers can use to manage those payments.
I can only imagine over the last 10 years that you have been in business and leveraging this cryptocurrency and the wallet and all of that, how much you've been able to build the number of transactions that come through your system and the number of customers as well as merchants in your system. So I guess one of the questions that I know I would want to know if I were the audience is, where did you get started with this? Because this is an area that is still really not well understood for a lot of people. So help the audience to understand, how did this get started for you?
Yeah, my history. So I'm a computer scientist, by training. Went to Georgia Tech, and I approached Bitcoin from a computer science perspective. And prior to Bitcoin existing, there were computer scientists trying to figure out how you could create a payment method for the internet that didn't require there to be one company to clear all the transactions. And there's a company in the early 1990s that I was very interested in called DigiCash. and they were using cryptography to create a secure payment system for the internet. But it was a centralized system, and when that company went bankrupt, that payment system went away with it. And I was just fascinated, you know, sort of on the side of, you know, of my career, just as a hobby, of projects kind of working on this problem. And I got to be honest, you know, late 90s and early 2000s, it was not looking very promising for the, you know, it was, I think a lot of people had thought that you're just always going to have a centralized company to clear transactions, make sure there weren't double spends and whatnot. And then Bitcoin came along and caught my attention. Late 2010, I started studying it, read the Satoshi white paper, and realized I was very fortunate that I had, you know, had a bit of knowledge, you know, for the previous couple of decades in this area. And I realized once I read the Satoshi white paper what mining was all about, how it was helping secure the network and ultimately look like it might actually work. And I got very excited about that. It happened to line up in my career with a time where I was looking to get back into a small company. And I started talking to my eventual co-founder about it, got him excited. He and I knew each other from Georgia Tech. And yeah, one thing led to another. We started BitPay. And at the time, there were already Bitcoin exchanges that existed. So we felt like we wanted to build a platform that would enable consumers and businesses to get, you know, derive real value out of it. You know, at the time we thought trading of these things would rapidly commoditize. So we wanted to build a platform. And so the idea, initially we didn't have a wallet or any kind of consumer service. It's all about a business being able to accept crypto for payment. And what we wanted to do was just very straightforward, build an API for those businesses that worked very much like their credit card gateway. And so they could just add us in as a payment method alongside the credit cards. And that's where it all started back in 2011. Wow.
And this is really early on when Bitcoin first really started out. So you really got into it really early in the game.
Yeah.
That's awesome. Mm-hmm. So I know with, you know, cryptocurrency, it's taken a long time for a lot of people to really jump on board and really understand it. So what are some of the issues that you see from a consumer perspective and really from a merchant's perspective, both of, you know, cryptocurrency, the usability, and really the uptake of it?
Yeah, well, I think both for consumers and businesses, it's intimidating. It's something new, and there's a different language and lingo that goes along with it, and so it just can be an intimidating thing to embark upon. And so we really try to make it as approachable as we can. We're constantly working on improving the user experience, making it simpler, you know, and yeah, so. You know, on the consumer side, it's a lot of times people just don't know, or they haven't really experienced it, or they just are unaware of how easy it can actually be, and so just getting them over that first step of installing an app and buying some cryptocurrency to play around with, really, and get accustomed to. On the business side. You know, we're a typical merchant. We might be 5% of their sales, and so it's like, you know, convincing them of the value proposition, which is, you know, yes, it's cheaper than credit cards, and there aren't chargebacks like you get with credit cards. You don't have the fraud issues that you get with credit cards. But even more compelling is there are now tens, if not hundreds of millions of people around the world that have cryptocurrency, and when a merchant signs up with us, we partner with them to try and help market their products and services to that audience and get them selling. Our goal is to not just be like, you know, 5% of their checkout. Our goal is to grow that to 10+% of their checkout. And most of those people that end up paying with cryptocurrency will be new customers for that merchant. So that's new customers and new revenue for them. And we've been very successful with that. We've been really good about raising awareness about our customers' products and services among the people that have cryptocurrency and want to buy things with it. Wow.
That's huge, and that's beneficial. Now, from start to finish, from when you started and where you are today with BitPay, how have the transactions grown? How have the number of consumers on your platform and merchants, without necessarily giving us specific numbers, if that's, you know, not comfortable for you, but, you know, percentage-wise, how have you seen that growth?
Well, the growth is like infinite percentage-wise. From day one, we had 0 transactions, but we would be happy in those early days in 2011 to get 5 or 10 transactions a day. Now we're processing, into the tens of thousands on busy days, and processing over $1 billion worth of transactions annually. Our average, the average purchase people make is around $1,000 per transaction. So it's significantly higher than what people spend on credit cards. But yeah, I mean, we're processing over $1 billion annually today, and I think a little over 5 billion to date that we've processed.
Now, from a regulatory perspective, because we know that the regulatory bodies did not really know what to do with cryptocurrency, and still till this day, they really don't know what to do with cryptocurrency. So, but have you seen like the big changes, and how has that affected your business?
Yeah, I mean, we've always been proactive and engaged with regulators. A lot of that over the years has been just education, meeting with them, getting to know them, getting to know us, and develop a relationship there, and but educating them about how it works and everything. And actually, I think a lot of regulators and they're interested and fascinated by the technology as well. So it has evolved over the years. Initially you would reach out to a state financial regulator, and they didn't know what to do or say, and we would proactively seek out, hey, do you want us to get a license? Are we okay proceeding without a license? And a lot of states reacted, well, we really don't know how to even think about what you're doing. Like a no action letter. It says, you can continue providing your service, and we'll figure it out later, basically is what that means. But over the years, different states have developed some, like the state of New York has a specific bit license that you may have heard about. And then, other states have, said you need to fit within the money transmission regulations that they have, and so on and so forth. And then at the federal level, they're also trying to figure out. The OCC has recently started to entertain the idea of crypto and fintech companies getting federal charters. And then there's a lot of questions about what, where the division lies between state level and federal level regulations. Then internationally, it's a whole, just a whole bunch of different stuff going on. So.
And you've got to keep up with all that. That's a lot for your business. Where do you see the trends headed in this space?
I think one thing I've been good about in my career is predicting things. And most of those predictions stem from economic pressures. And I think the economic pressures are there such that we believe that the future of payments is on a blockchain of some kind. Maybe it's Bitcoin, maybe it's dollars, represented on a blockchain. Maybe it's euros or other national currencies represented on a blockchain, or it could be fully public decentralized blockchains, or semi-private or private blockchains that are just using the technology to create a more secure platform. One way to think about Bitcoin and any blockchain is a new kind of database technology, and I think it's a breakthrough. It's a computer science breakthrough in that respect. If you look at Bitcoin, it is a database that's been going for since 2009. It's never been compromised. And a blockchain database sort of inverts the security paradigm. Instead of creating this database that you want to protect and create boundary defenses around and only allow authorized people in to make changes to it, instead you say anybody can make changes to it as long as they adhere to these certain rules. And then the whole network validates all the modifications to that database and then builds a consistent view of all the changes that have been ever been made to that database. And so that's game changing. And I think blockchains will be employed in all kinds of use cases beyond just payments. So where do we see it go? We see blockchains being the platform that people will use for payments. Our mission here at BitPay is just to build the best platform for companies and consumers to make and manage those payments.
That's awesome. And, you know, it's amazing because, you know, talking about how you're able to basically do the audit trail, essentially, of all the changes that are made on those wallets and on that blockchain. And then I guess, you know, lastly, it's just, you know, what are some of the challenges that are facing the industry? And you know, based on your predictability, and obviously you've done a good job of predicting because you started this at the inception of pretty much when Bitcoin started and you'd already had the idea. And then now here you are capitalizing on it, which is phenomenal. So what do you think are some of the challenges that are going to be coming up, and what are you predicting for how you're going to handle that?
Oh, you know, I think most of the challenges are just how do you get people actually to start using it and start using blockchains and crypto and make it approachable for them. And, you know, the real hard problem to solve is how do you get like everybody transacting this way? And I think it will happen over time. I hope BitPay plays a central, you know, key role in making it happen. You know, we're trying really hard to do that, and have been pretty successful to date. But yeah, there aren't a lot of people paying with crypto today, and we're trying to really change that and overcome that. You know, $1 billion sounds like a lot, but it's small in comparison to the big payments companies. Yeah,
that's true. It's interesting because I know now with us, what we do in this space and utilizing HPCC's systems, and I don't know if you're familiar with that big database. It's not a blockchain, but it's one of those systems that's able to allow for new rules on the back end to be changed very quickly. So we can code for those rules. So any rules or regulatory changes that happen in you know, in this space and any space really, we're able to go in, code it easily and update so that we can help manage a lot of those transactions that come through the system. And it's just fascinating that, you know, a space like yours and how you're mentioning all these predictabilities and these changes and being able to keep up with it and all the challenges that we're in our space where we are, that we're able to leverage a lot of those changes that are happening in order to be able to keep up with, you know, your environment, an environment like yours, right? Cryptocurrencies, payments, and this large volumes of transactions that come through the systems. And so, yeah, it's pretty exciting stuff that you guys have done at BitPay, and in the high volumes of transactions as well. So this is great, and I appreciate you taking the time today to be able to speak to us more about that, and telling us more about BitPay as well. Is there anything else that you would want the audience to hear about you and BitPay?
Go out, if you haven't done it already, go get a wallet and play around with some cryptocurrency, make a payment, buy something with it. And I think after you get through that first experience, you'll realize it's really quite easy and makes paying for things just a breeze. Yeah,
well, that's good to know. I know I originally started on Coinbase and then learned more about BitPay. So then opened up a BitPay wallet so that this way then I can learn more about how I can use BitPay to be able to transact and find merchants that are on BitPay to be able to make those payments. So it's exciting. So I thank you, Stephen.
All right, thank you.
So thank you for your time. So now that we've heard from Stephen Pear, the CEO of BitPay, I'd like to speak to you a little bit about our story here at DataSeers. So when I started at DataSeers, I didn't really understand what technology we were running on. And after learning more from the CEO and from our VP of engineering, I was able to leverage more information to really understand how it is that DataSeers is able to ingest so much data and process so much data so fast and take data from all different sources as well as different data types. I had no idea how they were able to do all of this. So this is where I learned more about HPC systems. And what's fascinating about HPC systems is the fact that in the environment that we're in, the space that we work in, we work on a global scale here at DataSeers. And so we have to deal with all the regulatory bodies that Stephen was speaking to earlier, and not only here in the States, but globally. So we need to make sure from a compliance perspective that we are constantly updating the regulations and the rules on the back end to be able to keep up with the payment space. And so having a technology like HPC Systems that leverages ECL coding that's fairly easy for our team to learn and be able to make those manipulations and those updates on the back end and keep up with this ever-changing regulatory environment is huge. And it's really been something that we've been able to leverage and use in the real world environment today. Now, the other thing too that I've learned since being here at DataSeers and leveraging a system like HPCC is that we're able to take our servers and slot the server in, well, run HPCC systems and keep going. And it's really easy in order to be able to get it up and running. That has been a huge operations wonderful thing to have happen. There's no virtualization needed, no VMware, which really helps us as well. The fact that we take in the data, ASCII, Unicode, unstructured text, and we can take it all in, we can handle all of that and be able to manipulate the data because we're able to homogenize it, we're able to clean it, we're able to map it all, and then be able to report against it. That has been really helpful too for our customers. And we've seen it with our customers, the difference between leveraging a technology like HPC Systems within DataSeers and be able to do all the data manipulations, all of the reporting that we're able to do, and they're able to get what they need out of the system whenever they're leveraging our technology here at DataSeers. I can't tell you how many times our own customers have said to us, wow, we've never seen anything like this. And then you add the billions of transactions that come through our system today. As Stephen mentioned, they alone are a cryptocurrency wallet that does billions of transactions. And so we've got such wallets on our system today. And then we've got other cryptos on our system today, as well as banking and other financial institutions and other fintechs. Can you imagine all of those transactions coming through our system, which I think you can imagine because clearly you know about HPC systems. But for us, operationally, it's unfathomable. And then the volume, the variety of the data, and the speed at which we're able to process, which is so important when you're in the payment space. So to be able to take it all in, be able to process it, and to be able to do it all at what I like to say is lightning speed is phenomenal. So I am just thankful that DataSeers has partnered with Lexis to be able to leverage HPC systems for us to be able to run operationally the way that we do and so successfully. So I want to thank you for allowing us the opportunity to be able to invite you all into learning more about DataSeers and how we're leveraging your technology in the real world.